One of the things that was brought up in the keynote is the challenges around component teams and the very attractive option of organising people around that, if you like, that grouping. What things did you bring out about component teams that really caused it to fail?
Right. So what a lot of people, first of all, let me define my terms because I'm not sure all the audience will be aware. So what we mean by component teams is groups of programmers that just specialize in one software subsystem. For example, a real simple example, a group of programmers that just do the UI layer, a group of programmers that do some middle tier, a group of programmers that do database stuff. Or in my world, the larger scale, when you've got millions and millions of lines of code and lots of subsystems, programmers in this subsystem, programmers in this subsystem. And then when you want to do a customer feature, it needs to be split up between all of these component teams. So that's what we mean by component team. Now, what a lot of people don't understand about component teams is what it leads to if you have a component team, the organizational implications. So to paint a picture of it with words, if you have a requirement, F1, and it has to cut across 5 components and therefore across 5 component teams, the first question you need to ask is who's going to do the requirements analysis for it. And if you've got 100 component teams, it's not at all clear which of those 100 do the requirement analysis, and they're programmers anyways. So we give it to somebody else. Let's call it the requirements analyst or the business analyst or the specification group. And they do some kind of requirements document. Now, if you have 100 components and 100 component teams, the next question that you need to answer is which of these 100 components is touched by F1, and what are the interfaces between the components involved? Now, which of the 100 component teams is going to answer that question? It's also not at all clear, and so we'll create some upfront group to answer that question, usually called systems engineering or the architecture group. And they'll take as input something created by the requirements group, and then they'll create some kind of an output describing the work to do in each component, the components needed, perhaps the interfaces between the components, and so forth. Then we're at the step that the programming can finally happen, and so then the work is given to the 5 different component teams, and they do their bit of the work. But it's important to understand that the way I've described the story almost sounds like everyone's just sitting around sitting there waiting for F1 to come to them. But in fact, there's F2, F3, F4, F5, and all of the work's been chopped up, and it's either in queues before each different work group, or they're doing work out of order, or they're partially allocated across multiple features at the same time. So the work is being done out of order. And if you've got, for example, 5 component teams working on F1, one of those teams might do their part in January, and another team might do their part in June, because it's all out of order. Finally, all of the programmers have finished their work on their components, and we need to do the end-to-end testing for F1. Who's going to do that? Will it be the first component team, the 4th component team? It's kind of arbitrary and not at all clear, so we'll give it to a separate group called testing or systems testing. So what do we have here? We have a group that does requirements analysis, that hands off their work to a group that does architecture and design, that hands off their work to a group that does programming, that hands off their work to a group that does the final testing. In other words, a sequential life cycle. And so it's important to understand that if you have component teams, it inevitably generates a sequential life cycle with all kinds of levels of handoff, delay, multitasking, and the myriad wastes in lean thinking of overproduction and so forth. Like, for example, one of the wastes in lean is work in progress and overproduction of features or inventory and so forth. So if you're a group of just systems engineers or a group of just requirements analysts, it's not like you're just going to sit there and not do things. You have to keep busy. That's, from this local optimization view, the important thing. So when you've got these single specialist groups based upon, or driven out of having component teams, everyone is busy creating documents and content or work in progress for the next group as well. So you get very high levels of WIP. Also, let's suppose you've got 100 component teams. Component team 5 has to keep busy doing component team 5 work, irrespective of the actual value from the customer perspective. So what happens is that you optimize the choice of requirements not around value to customer, but around keeping people busy. So to put it in Scrum terminology, you might take some relatively low priority item and start working on it because otherwise component team 5 wouldn't be busy. So you don't have the case then of everyone's working on the highest value stuff. That's another negative that comes out of this. Furthermore, you've got F1 chopped up across all of these different groups, so you could drop the ball on it because it's not being done by one group end to end, and consequently we need to solve that problem somehow, which is usually solved by adding an overhead role called a project manager or feature manager, and then this role is responsible for keeping their eye across this feature as it goes across everyone. So we've added more unnecessary overhead, more coordination problems, sub-optimization on keeping people busy, more WIP, and a very slow organizational design that all arises out of the assumption that programmers could only possibly work on one little chunk of code, that it wouldn't possibly be useful or skillful or even possible for programmers to work on two different things. And it's, to me, fascinating how this extraordinarily large, inefficient organizational design essentially derives from that key assumption, the mental model that programmers can only work on one little piece of code, which is fallacious. You know, it's not at all true. So the alternative is to move to Agile teams, Scrum teams. And in Scrum, or in any Agile team, the idea is that the team is what was traditionally called a feature team, that this team is cross-functional, cross-component, and they contain all the skills within them to do everything end-to-end. When we're talking about changing the organizational design from, say, a traditional sequential lifecycle with component teams to a large-scale Scrum model, what it means then is that the people in these different single-function departments, requirements, systems engineering, programming teams, test, all of them will leave those groups and they'll form new groups, Team Blue, Team Red, with people from these different single specialist groups. And ideally with programmers in a team across different components, so that then within the team you've got people with skill essentially across the stack, so that then this cross-functional, cross-component feature team can be given end-to-end work. They can be given the goal F1. They can do the requirements analysis, the design, the programming, and the end-to-end testing as well. Now, there's a scaling question, which is that kind of transformation works relatively simply and straightforwardly with little groups of, let's say, 5 or 10 component teams moving to now cross-component teams. But in the world that I work in, which is often 100 or 200 teams, you're not going to be able to create teams of 7 plus or minus 2 people who know the code across the entire stack of all 50 million lines of code. So how can we address that problem? Well, then a solution from large-scale Scrum Framework 2 is to have what are called requirement areas, which are areas of requirements organized from the customer perspective, like transaction printing or color printing or protocol support or options trading or whatever. It's a requirement from the customer area. And then have groups of feature teams that just specialize in that area. Now, that area is not necessarily isolated to a particular subset of code, but odds are that a requirements area, which is an area from the customer perspective, nevertheless tends to work in a predictable subset of the total body of code. So this tends to reduce the learning burden so that then a set of feature teams working in one requirement area are more likely to still be able to work an end-to-end feature with enough knowledge within it. And then if they don't, then they're just going to have to face the learning challenge of starting to work in components that they know less about. And if that's the situation, then we need to address the problem of the team essentially working on code they might not know very well. And then we can use other techniques to address that potential risk, such as a component guardian, someone from another team who knows that component well and looks at their code or participates in a design workshop with them in order to help them. Another related transition technique for moving from an organization with a lot of components to cross-component feature teams is a baby step where instead of moving to truly cross-component teams, you start by making teams that just work across a larger set of the stack, but not across the entire thing. So suppose, for example, you had 50 component teams, and the 50 component teams were organized into 10 teams in layer 1, 10 teams in layer 2, all the way through layer 5. Then in layer 5, your original design could be that one of the teams just worked in that little bit and this team worked in this little bit. Well, what you can do in layer 5 is that you can mix up those component teams to create teams with cross-component members, but they only work in layer 5, but you can mix them up so at least each team can do anything in layer 5. And so too with layer 4 and layer 3 and layer 2. And then when you have to do a feature like F1 that cuts across layer 1 through layer 5, you'll still have the problem of handoff and multiple programming teams that are only doing part of the work. But you'll have reduced the number of handoffs from maybe 20 different teams to now only 5 different teams, which has benefits as well. And then maybe over time you can go from having teams that just specialize into a layer, where, for example, you take teams that are just in layer 5 and teams that are in layer 4 and remix them, so now that you've got a team that knows, some of the people know stuff in layer 4 and some of the people know stuff in layer 5, and now you've got teams which are a little bit more flexible. And in some of my customers that are very large scale, we take that kind of baby step as well. I think that's kind of an introduction to the component. That's the short answer to the component theme issue.
You mentioned the role of component guardian.
Yeah.
And I've seen it abused as a role. It can be seen as quite a position of power. And it almost can be abused to the point where people use it to ring-fence their knowledge. It's almost a badge. What negative behaviours have you seen around component guardian? Is there any advice you can offer to someone who said, you are a component guardian?
I'm going to generalize the answer first of all. Well, first, specifically, the usual mistake with component guardians is that they have check-in authority related to the code that other people are adding. In other words, they're a committer role, to use open source terminology. And you don't normally want that unless it's like a safety critical issue where you want to optimize the system on, say, on life safety, and you're willing to sub-optimize the delivery of value. My context is always that we're optimizing on the delivery of value to the customer. That's a higher priority than life safety or other things. So my answers are in that context. So in that context, if delivering value fast is your optimizing goal, then if you have any kind of a process where a person acts as a gate, you will introduce all kinds of delays and problems. And the generalizing comment that I want to make is that if you have any kind of processes where somebody creates something, then there's a delay of time, and then at the end there's a gate and a quality inspection before something can go through that gate, we have a problem. And there's in some quality communities, you'll sometimes hear the phrase, quality gates imply a failure of quality. And whenever you install quality gates, inspection steps, and so forth, you're not actually addressing the root cause. You're just putting a Band-Aid on the situation. Because the idea in Lean is to build quality in so that you wouldn't need a quality gate to try to inspect and correct defects out. In Lean, one of the wastes is defects, and then all of the knock-on effects from defects, like inspecting and correcting. So reviewing a document and then handing it back, testing code and then it failing the test and handing it back. All of those are part of the wastes in Lean thinking, the wastes of defects. Better to build quality in. So instead of a component guardian acting as a committer who waits for someone to send them the final code so that they can review it and then check it in, better to build quality in where that component guardian is a component teacher and they go proactively ahead of time and work with the team that's going to be working in the component that they know best about, participate in a design workshop or pair programming, or in that way help educate someone on the team to know as much as they know so that their job as a component guardian is no longer needed. In other words, they're always trying to work themselves out of a role through continually teaching. It reminds me of a story. Some years ago, I was working in Paris at a bank called Société Générale, and they were starting to do a Scrum adoption in a particular subgroup. And one of the managers told me a story. He told me that when the new CIO of Société Générale joined the company, on his first day, he asked his direct reports, please bring me the name of one person in each of your groups which you consider absolutely critical for delivering your systems into production. And on the second day, his direct reporting managers gave him the names of these supercritical people. And then the CIO said, these people will not be allowed to work anymore. And this is such a rare example of a leader with real systems thinking insight. He understood that those people aren't your strength, they're your weakness. In Canada, we would call it the truck number of your project. How many people have to get hit by a truck before you're in trouble? Or here in London, I think it's called the key man problem. And so the CIO said that after this point, these people, all that they can do is teach other people. I want them only working with others and acting in roles as teachers. So it's the same thing with good component guardians versus dysfunctional component guardians.
Do you see, the other talk you've delivered is on outsourcing and contract negotiation and the challenges associated with scaling out in that way. This type of role of component guardian stroke teacher, does that become even more critical when you are trying to push out into other cultures, other organisations, trying to engage with an entirely different group of people?
Yeah, absolutely. I think I'll first of all answer the question in the context of what I call the four-year programmer problem in outsourcing to offshore locations. And this is, I haven't worked in every country in the world, but I've seen this, for example, in India and in China. And I'm not really trying to pick on the country per se. These dynamics could happen in Canada, where I come from. They just didn't happen to. So in India, for example, it's quite common that the university professors, smart as they are and well-educated as they are, know close to zero about the craftsmanship of programming. They really don't know how to work as professional programmers. And so so-called computer science students coming out of the Indian or Chinese universities, they learn very little or close to nothing about how to be good professional programmers in those countries. And it's really not much better in Canada, where I come from.
It's certainly not much better in the UK, to be honest, I think.
But maybe a little bit better. So they come out of university, say in India, knowing squat about how to be a programmer. Then their goal is to stop being a programmer as fast as possible. And I call this the four-year programmer problem. So in like China or India, okay, well, I'm willing to be a programmer for 4 years, but then what I really want to do is become part of the overhead management, because that sounds better and I can make more money and so forth. That's perfectly rational, if that's the only way that you can make more money. But what it leads to then is organizations in these countries, outsourcing organizations, full of people with quite low programming skill. And furthermore, where there isn't a culture that values clean code or great code, and there's not a culture of master programmers. So, and this can happen in any country, but it tends to be even exaggerated worse in these offshore outsourcing contexts. And so the role of a component teacher, say, to play it out with a concrete scenario, we've got a bank in London. They've got developers inside of the bank who really know the code well. They've been there for 5, 10 years. They know their stuff. And then they're required by some HR policy or some CIO policy, you must work with outsourcers because we will save money that way, which itself is really highly fallacious, and you can unpack that whole assumption, and it's often not true that the value for money is not there. But leaving that aside, so they're forced to take on working with an outsourcing group in the probably mistaken belief that it's actually going to save people money. Then in that case, the programmers that they're working with are unlikely to produce great code. The first thing that I recommend when you're choosing an outsourcing partner for an Agile engagement or any engagement is pay no attention to what the salespeople in the outsourcing group say about the quality of the people. Pay no attention to their claims about CMMI certification level. That's all just blah, blah, blah. Look at their code. I've told the story many times before. Valtech, where I used to serve as chief scientist, was considering buying a company that had CMM level 4 certification. And we decided to actually do a project with them, and then rather than just listen to their claims, actually look at their code. So we did a project with them where essentially we were the customer. I'm not even sure they knew we were considering buying them at the time. I don't think they were. And then we looked at the code that they produced, and it was utter crap. So we didn't buy them. But the point is that you have to go see, as they say in lean thinking, go see, look with your own eyes, spend time sitting with the real development teams there, spend weeks working with them, see what they're really like, and look with your own eyes in depth at the quality of code they create, and choose your programming partners based upon that direct insight, rather than any indirect claims from salespeople or assessments or ISO levels or what have you. And then thereafter, when you find a group of great talented programmers, try to keep them forever. Pay them whatever you need to pay them to keep them as programmers for 20 or 30 years. A culture of paying people a lot of money to be master programmers. And try to develop a culture in these offshore development organizations where they start to value master programmers themselves rather than establishing a culture of promoting people out of the value work into overhead management roles. And while you're working with the programmers, have your local component guardians and your local onshore programmers establish a role of coaching and mentoring with them. Now, I've noticed that sometimes this leads to turf problems because the onshore people, let's take the case of London, they'll feel probably threatened by potential loss of job security and so forth by these new people coming on, and they might not want to help them as teachers because that they might feel like they're working themselves out of as a job. One of the key lean ideas is job safety but not role safety. So the idea in lean is that there's no way that we can deeply and dramatically improve the system, the organizational system, unless we can deeply change the organizational design, which implies that roles may disappear. For example, like in Scrum, we no longer need the overhead role of project managers and program managers. But all of these good people in project management or lead technical people, out of respect for them and in order to get real improvement, we need to have job safety for them. So we need to somehow communicate and have the policies that while you're acting as a teacher to these people, you won't be working yourself out of a job. Other value-adding roles will arise or exist for you. But what we value is teaching. It reminds me, some years ago when I was in Japan, I went there with my co-author, Bas Voda, and did some interviews at Toyota in Nagoya and Toyota City. And we interviewed some Toyota people about their HR policies. And one of the things that we found is that in Toyota, they actually measure people upon the question, how much time are you teaching other people? And they especially measure managers on this. There's this culture in Toyota of manager as teacher. The saying in Toyota is that my manager can do my job better than me. And a key job of the managers is to continue acting as teachers, both of lean thinking skills as well as the hands-on work, whatever it is. And so this is a culture, the lean culture is a culture which really values people, senior people, managers who are acting as teachers. And I'd like to encourage that in when we start working in with offshore teams as well.
It seems to me, certainly over the last 5 to 10 years, I would say now, 10 years probably, that people have become front and center in software development. We're coming back round to the people matter. And interestingly, as you say, people have in the past almost wanted to promote themselves out of doing value work. Also see that in offshore initiatives where, in effect, you end up with an organisation that's onshore that essentially represents, I guess you could phrase it as waste. Have you had to consult and work with any organisations where that has been a direction that they're dangerously heading towards? And what sort of things have you advised them to avoid that trap almost?
Yeah, so well, first of all, to state the obvious, or just kind of describe the situation that typically exists in the mentality is, oh, we're going to have the important people, the management overhead and so forth in Rome, and then we'll have the unimportant people, the coders in Shanghai. It's that kind of mentality. And before I kind of answer your question directly, I want to go to a geopolitical level. You know, you can outsource the management too. And in fact, as groups that master Scrum and Lean and Agile practices well know, you need almost no overhead management. It's discovered to be truly a wasteful job. You have self-managing teams which work quite effectively. The combination of those... and here's another point. Inevitably, if you set up a site somewhere that does the hands-on value work, and I've seen this all around the world, inevitably management moves there because the bottom line is that that's where the value is being added. And one way or another, that's what happens. So let's play this out into the future. We're in Italy. Not, I mean, we are here now, I'm just painting a picture. We're in Italy, and we have the mindset that the important work is the overhead management role. And we create organizations where nobody has the skill to do the hands-on value work, and all that we can do is do Microsoft Project and so on and so forth. Contract negotiation and all of that stuff. So play this out 10, 20, 30 years in the future. What's going to happen? People aren't going to have any jobs in these countries anymore because the bottom line is where the value is being created. And simply what will happen is that all of the value work will shift to China, India, and there won't be people in first world countries who are acting as hands-on value creators, hands-on engineers, designers, scientists, what have you. And I don't mean to imply that we shouldn't encourage success in developing nations. It's a big pie and a potentially growing pie. And I've got kids that have grown up now. And if you ever go to especially a very poor country, and you see little kids on a street who are obviously not advantaged, you, as a parent, you naturally hope to see them have a better life. And I want to see developing nations succeed economically. But I don't think that needs to be at the expense of existing developed first world countries. But it will be at the expense of developing first world countries if we promote this culture of overhead management and people who do handoff in these countries and the engineering work is being in other countries. We need to establish a culture of hands-on great engineers, scientists, designers in all countries. And we know the world is becoming flat. And in this highly competitive world where we have to shave off all of the waste and all of the inefficiencies, we can no longer stand in this highly competitive world, a world that can afford a lot of overhead management. Self-managing teams and self-management, which is the 11th Agile principle, is not just a nice-to-have idea in Agile methods. It's going to be a critical requirement to stay competitive in the future as well. And I know I've kind of taken a bit of a tangent on your answer, but I think it's the larger picture that needs to be communicated. So your original question was, how do you deal with organizations where I'm seeing that kind of problem? And one of the things that I first do is talk about this very point. I play it out over time. And then I'll tell stories from companies I work with where I've seen the shift and then the gradual reduction in the first world country sites, because I often work with companies over multiple years, and so I see the shift over time. When companies first start this, they have the fantasy that, oh, we'll be able to have lots of big, expensive, important jobs here in London forever. But I look out over 5 or 10 years with my customers who are doing this, and it's very easy to see the trend that that's not what's going to happen. And so I normally start by sharing that, and then ask the question, how can we do things different? How can we move to a culture where everyone's doing hands-on work? And are you part of the next generation of becoming a skilled value worker, or are your only skills in overhead management?
Makes good sense. You've had a lot of experience with a lot of organisations around the globe, and you work on large projects. I think you've given us some statistics in the talk today of what, almost the level that you start at. You don't start at the very small, you start at the very big and get bigger.
Yeah, like I often have a filter that I get a fair number of requests for work, and if it's less than 500 people per product group, I don't usually take the work anymore. It's just to try to manage the work.
I mean, it must be a very interesting space to make change happen, really, and to help people control that. What is the most common mistake at that scale that you see? I mean, is it the component teams? Is it...
I'm not sure I can exactly rank them, but the big ones that come up repeatedly are, number one, what in Lean is called the waste of working to job title. In large organizations, the whole mindset is, you're a systems engineer, that's all you do. You're a programmer in component 3, that's all you do. You're a project manager, that's all you do. And you could say the mistake or the challenge in these large-scale adoptions is breaking that waste of working to job title mentality. And it's not just an individual person. The whole organizational structure is wrapped around that. You have the business analysis department. You've got the systems engineering department. You've got the testing department. And so dissolving all of those groups has implications on the existing management structure and job careers. And breaking people out of that mentality is a real challenge. So even if you start to form in these organizations an ostensibly cross-functional, cross-component team of 7 plus or minus 2 people, usually the mistake that happens, just focusing now down at the team level, is a requirement comes in and the person previously known as the tester says, well, there's nothing I can do for the next 7 days because there's no testing tasks yet. Or the person previously known as the business analyst says, well, I've finished doing the business analysis, so there's nothing more for me to do. And so then a very common mistake is that they increase their WIP levels, their work in progress levels, by then the business analyst going on to working on the analysis for the second item, where the other people are working on the programming for the first item, and so on and so forth, instead of whole team together with multi-skilling, taking on secondary or tertiary skills, and learning to do one thing at a time and working outside of their comfort zone. It reminds me of an interesting experiment that we talk about in one of our books. There was a group in the United States that was applying an Agile development method. I think it was XP. I don't think it was Scrum, not that it really matters in the context of this story. And they measured their velocity over a series of iterations where they applied the policy of most qualified person, where the person most qualified for a task always chose it. and they measured their velocity. Then, after X number of iterations, they flipped the policy to least qualified person, where on purpose, the person least qualified to take on a task always chose it. After 3 iterations, their velocity was higher than it had ever been before, which always strikes me as a fascinating story. And I don't mean to imply that other groups' results are going to be the same, but it's a very telling story about the assumptions that people have. And it's related to the assumption that the important thing is optimizing how busy a person is, or optimizing how fast one person works, which is not the lean view. The lean view is how fast can we deliver an entire thing from the system? How fast can we deliver value to the customer? And from that perspective, handoff delay or bottlenecking with single specialization is often the dominant issue. And even if people can do things slower, but they can do 3 things, you'll deliver value faster. And from a lean perspective, that's what's important. Another big, I'll say, mistake or challenge in these large organizational adoptions is that they'll typically have a large amount of management overhead. Project managers, program managers, and they even sometimes have a project management office. And they mistakenly believe that you can adopt Scrum and still have all of this overhead management, which of course doesn't work at all. If you write down a list of all of the project management responsibilities, just make a list, and then identify the 3 roles of Scrum: Scrum Master, Team, Product Owner, and you take that long list of all of the project management responsibilities and say which of the 3 roles they go into. Fact, they will find a natural place into those 3 roles. Most of them will go into Product Owner and into Team. So the point is, in Scrum, virtually all project management responsibilities in proper Scrum are allocated to the Product Owner from business or to the self-managing team, which therefore means that if you still have around the old traditional project or program manager role, it's going to gum up the works, because what are they going to do? They're going to interfere with the proper Scrum model, and we won't have self-managing teams, and what are they going to do? Well, what do managers do? They have to manage. And so it will create various kinds of problems. They'll be taking on the things that the Scrum team should have been taking on. And this is a delicate political issue, because these are often very bright people, talented. They've put in years of hard-working time in the companies. And it's not like I'm trying to imply that I don't value their native intelligence or their contribution, but it's back to this lean principle of job safety versus role safety. The role of project management and program management is simply no longer needed in large-scale Scrum organizations. And the leadership that's planning this transition needs to address this and find new work for these people, which, by the way, is why for large-scale adoptions, bottom-up adoptions don't work, because we're talking about deep changes in the organizational design, and that's going to require the decision-making by leadership in changing of roles, new work for people in traditional project management roles, and so forth.
Gotcha. So there's a lot of talk at the moment around how to encourage people to learn, how to get a team, or encourage a team to understand that learning is necessary and important. And there's a little bit of confusion out there around the coach role, there's the mentor role, there's the Scrum Master role. Where do these responsibilities sit, or is it a moot point?
The very quick answer is, I don't know. That's painting a little black and white, but I've not thought about this question very formally, so I can only kind of answer it anecdotally rather than with a lot of careful thought and reflection. The first thing that comes to my mind is that the people in my life that have had the greatest influence on me was primarily from their behavior. And I've been fortunate to work in my life sometimes with some people that I consider just frickin' great people in product development, in software, and so on and so forth. And then a corollary from that is that if we want to create teams that demonstrate learning, then we, the people that want to inculcate that kind of behavior, I think will need to demonstrate that in ourselves and our own behavior. So if there's some core set of what I'll call organic leaders in the organization, Scrum Masters, natural leaders who have been around for a long time, managers in the organization and so forth, have a discussion at this level that we all need to be demonstrating multi-learning, which is a key Scrum idea, rather than just a single specialization, that we're taking time during the day to be reading books, that we've got piles of books on our desks, that we're going to courses regularly, we're going to conferences, we're reading, we're starting brown bag lunch sessions in which we're going through a book and inviting other people to listen with us, that at 5 p.m. each day we're organizing sessions where we invite people to come and we show them what we've learned. And then in that way, I think we might be able to give the spark of learning to other people. So that's one thing that comes to mind. Another thing that comes to mind is that if you're a group of 7 testers together in a room and your manager is a tester, well, what are you going to learn about? Testing. Okay? And you're a group of 5 programmers in a component team on Module 4. And all you do is work on the 7,000 lines of code in Module 4 for 3 years. What are you going to learn about? So your opportunity for learning is kind of quite bounded as well, which can also then lead to the mindset of getting out of learning. So it's important to notice how single function teams and component teams systemically set up the culture and environment where people stop learning as well. In addition, when you reorganize into cross-functional teams and cross-component teams, so you and I are on a team together. You're an expert in UI design and Groovy. And I'm an expert in specification by example and acceptance test-driven development. So now I've got tremendous opportunity to learn from you and vice versa by virtue of the fact that we're in the same room together. And because in Scrum the only job title is team member, you're no longer business analyst or tester or whatever, and then there's all kinds of tasks on the wall and I could pick something from my secondary specialty or tertiary specialty, then through pair work with you, if that's your primary specialty and I'm taking on a task that I know less about, there'll be new opportunities for learning. So what I'm trying to say here is that through the Scrum model, we set up the organizational environment that creates the opportunities for learning, which don't exist in traditional organizations as well. And then another element that I've seen that can help is to formally ask the question with the team during a retrospective. Team, we have some kind of imbalance of the team specialization to the requirements that we're getting in. Why don't we formally identify secondary specialties? So in some groups, it's useful to actually say, well, my primary skill is testing. There's no way that I'm going to be able to learn how to program. That's just outside of my scope. But I'm really interested in UI design, and I'd like to take that on as my secondary specialty, and I want to go on that course, and I want to get these books, and I'll spend time with this person and this other team who's a specialist in that area. And so in that way, having these conversations formally about secondary specialties can also structurally set up the environment to make it happen. So then a combination of organic leaders demonstrating learning with an environment that is designed to support learning might provide the spark for people to actually learn.
Thank you very much, Craig.
All right,
Wonderful to chat to you.